In this video, I'd like to talk about dividing quadratics by linear expressions. And in all of these problems, we're not going to end up with a remainder. So we'll be given some quadratic expression in the numerator, and we're going to divide it by some linear expression in the denominator. So let me just rewrite this problem. And basically, the strategy for these is you want to see if you can factor this numerator, this quadratic expression, and ideally, it will factor into x plus 5 times something else, and we'll be able to cancel out the x plus 5 up top and down below. If we can't do that, if this doesn't factor, then we'll have to use what's called polynomial long division, which is a bit more complicated. And before we jump into doing this problem and factoring the numerator, I want to point out that this quadratic is divided by this entire expression. And essentially, each of these terms are divided by this x plus 5. So you want to be careful making some of the common mistakes. Sometimes students will maybe divide this one by x, maybe they'll divide this one by x, and then divide this by 5. You cannot choose which term in the bottom divides into which term in the top. Each term in the top is divided by the entire expression in the bottom. So one way that you could write this, and we won't do this for this problem, but you can write it as this first term divided by this entire expression, x plus 5. This second term, 10x, divided by the entire expression, x plus 5. And lastly, 25 would be divided by that entire expression. So each of these are divided by x plus 5. And you can see that this is true because we're essentially adding fractions here where they all have a common denominator, so we could just add straight across the top and get back what we started with. So this is how you want to think about these, just so that you don't make those common mistakes. And for this problem though, this actually won't help us, but it's just a different way of thinking about it, and sometimes this does help us in solving the problem. So I'll leave it up there. But for our problem, we're just going to factor this numerator here. And all of these problems, we're not going to get a remainder. So these all will factor. They're designed to factor. But like I mentioned, if you come across one where your quadratic or whatever polynomial you have in your numerator, if it's not factorable and you can't make nice cancellations, then you'll have to use what's called polynomial long division, which will be covered in a later video. So we have this quadratic, x squared plus 10x plus 25, and quadratics will factor into a product of two binomials. And since the coefficient on x squared is 1, we know that this has to be x and this has to be x, since when we distribute, you would get x times x, which is x squared, which is our highest power term here. If the coefficient is not 1, then you will have to try what's called the grouping method, which is a little bit more complicated, but is still straightforward once you learn the method. Now, to figure out the other terms in these binomials, we know that when we multiply this out using distribution or the FOIL method, that these last terms will multiply to give us our constant. So we need to think which numbers can multiply to 25. And we can list them out, 1 and 25, or they can both be negative. It could also be 5 and 5, or minus 5 and minus 5. And to determine which of these pairs it would be, we also know that they're going to add together to give us this coefficient on x here, this 10. So which of these pairs adds to 10? That would be 5 and 5. So we can put plus 5 and plus 5 here. And we ended up getting what we wanted since we have an x plus 5, or actually two of them up top, and we have an x plus 5 down below. And it's essentially the idea that if you had maybe a times b and divided by a, no matter what a is, that you can make this cancellation because you're multiplying here. And we can cancel out one of these x plus 5s up top and one down below because something divided by itself is always equal to 1. So this will just simplify to x plus 5 divided by 1 or multiplied by 1, which is just x plus 5. So our answer here, which we can put in the box, is simply x plus 5. And once you learn polynomial long division, that is one way that you can check these, though it can be a little bit tedious.